So we're going to record this and put it on YouTube, so don't say anything naughty. Good? All right. Everybody, thank you for coming. Welcome to the New York Practical AI Meetup. How many have you been to one of these before? Awesome. So you're all kind of newish. Our kind of goal with this meetup is, what the name says, is to kind of introduce people to the reality of creating a product or doing a project in AI. A lot of times we'll have people that are entrepreneurs talking about how they created their product, whether it was voice, whether it was using ML, whatever it was. Today we're going to talk about two things. One is Greg Ray from the Creative Destruction Lab is going to talk a bit about what they do, which is kind of fun. I'll talk at a very high level about Tensorflow, because for those of you that are interested in using ML, AI, Tensorflow is a good way in. There's a lot you can get done. It's part of the Google Cloud kind of platform, which means a lot of things easily connect to each other, which we'll discuss. It is not really a technical discussion. At the end of this, I'll point you towards some things, tutorials and all the rest. Tensorflow's got some fantastic tutorials. If we have time, we can go through one a little bit, but honestly, it never works when we try to code live with 30 people in a room. So happy to, as I say, answer questions, and we'll post some more on the meetup afterwards. So let me go through a couple of things. Thank you to Samsung Next. Yay!
Yeah.
Our friends Carl and English, who are not here tonight but have helped us with some things. So this is me, intros and community announcements, which I'm kind of doing now. Greg will talk in just a minute, and I'll go through Tensorflow. Guys, stop us at any point and ask questions, especially on the well, both of them really, because it's a nice group. So yeah, Greg, over to you.
Sure. Thank you.
We're not using the mic. Can everybody hear all right? Can you hear in the back?
What'd you say?
Awesome.
Trying to stand the beautiful logo. I'm Greg Ray. I'm from the Creative Destruction Lab here in New York City. Creative Destruction Lab, I'll give you like 20 seconds about it and tell you about kind of how it came to be and what we actually do. So, Creative Destruction Lab, we're a program for early stage science and technology companies, so it's everything from information sciences all the way into the life sciences. We support these companies as they go through the process of taking on financing, generally anything from pre-seed up to kind of Series A. It's a free program. It's kind of a nice little thing. Here in New York, we're housed out of NYU Stern, but we're agnostic to companies, whether from NYU. The program itself was actually founded back in 2013 at the University of Toronto in Canada by a guy named Jay Agarwal. He used to be my professor, then he used to be my boss, and then he wrote this book. I put my name in it somewhere, so it was kind of exciting. But if you want to learn more about kind of our economics behind what we do and how we think about startups, you can learn a lot if you get the book. I'll just kind of touch on it superficially.
I was going to give a plug in a second.
So if you want to take a picture of it, that's what it looks like. So it's called Prediction Machines. The kind of the genesis of the Creative Destruction Lab was that there was some research being done on kind of the disparity between where academic research and whether it be computer science or life sciences was actually being undertaken and where it was being commercialized. So if you look at where the research dollars, for example, go in healthcare, you would see that that's kind of well distributed across all the university towns in the country. But all the money that's going into venture is a little bit in Boston, a lot in San Francisco, and pretty much nowhere else. And so the questions are about why was there an inequity? Professor Agarwal in his research basically concluded that a big part of that was there's a lack of judgment outside of those kind of big entrepreneurial centers to support people who have technical innovation they want to turn into a product. And that ultimately, because that's not in place for them, they either don't become successful, they fail at it because they're not supported, or they decide not to pursue it because they don't actually realize it's an opportunity for them. So he started by saying, okay, I'm going to take some successful entrepreneurs, put them all in a room with some early stage companies, and kind of start working through it. I started with general science, and then he started realizing there was a trend towards artificial intelligence companies coming out of people like Jeffrey Hinton's lab at the University of Toronto, where he was based, but other institutions as well, like the University of Waterloo. And at that point, he said, okay, maybe we should double down on this artificial intelligence thing. It seems like it's going to be a big thing. So in 2015, they doubled the size of the program, focused specifically on artificial intelligence in Toronto, and started getting people like Coastal Ventures flying out from the Bay, people from New York, like Bloomberg Beta getting involved, and a number of other firms. And at that point, they started to generate some real enthusiasm. they put through companies like Atomwise, a company called Dalmic Labs went through there as well. They're now called North. And over the course of about 5 years there, they were able to generate about $2 billion Canadian in equity value for the companies that went through the program. At that point, they got other universities, including the one I work at now, New York University, contacting them saying, well, we want to do this too. And at that point, they started expanding it out. And so now we're about to start launching our second cohort here in New York. We'll have half health science companies, 25 of those. We'll have half information science companies, so it'd be companies doing AR, VR, AI, ML, data science kind of across the board there. And that would be what our cohort looks like. In terms of our program, it's a free program, so companies don't have to pay to participate in it. It's totally paid for by corporate sponsors, hopefully like the beer I just had here, which is really nice. So we don't touch people's cap tables, we don't take any equity. We support these companies by giving them access to successful entrepreneurs, so people like David Tisch, Kevin Ryan. So Kevin Ryan's built DoubleClick, MongoDB, Gilcrew, Business Insider. It's kind of a big deal, I guess. As well as access to capital, so to meet different kind of VCs, and access to scientists and economists who can help validate companies. We also let our companies work with our MBA students, and that's kind of how I got involved initially. I was one of the MBA students in the second year of the program in Toronto. Went and worked professionally. Then I got a call from Professor Agrawal saying, well, move back and work for me, and that's how I got involved as an employee. So it's kind of neat that you come full circle that way. I guess the interesting is we start to think about what companies we put into our program. You know, a lot of you guys, if you're thinking about, you know, coming from this space, then ultimately building out products or building out companies from here, you'll be the kind of companies that we get excited about. We want to support really compelling founders who are building technically innovative things. So when we think about what is compelling for a founder, what is compelling for a venture, we like to think about how they change the economics of whatever vertical they're interested in. So if you're doing something that lowers the price of something that already is happening in the market, that excites us. So if you want to think about, I guess, artificial intelligence more broadly, the way you would think about it is that's lowering the cost of prediction. So you say, in whatever vertical, if you lower the cost of prediction, what becomes possible? We're looking for the companies that are exploiting those things that are suddenly becoming possible. And that's what our kind of whole thesis is around. So yeah, I mean, that's the kind of the quick run of it. And yeah, I mean, I'm happy to, I guess, tell you more about the program if you want to grab me afterwards. But we're doing pretty well here in New York now that we're just finishing up our first year. We've had one of our companies, I was at their party last night, they just raised $4 million, so they were opening up a new office and had some very nice champagne, so hopefully it's not a trend for them, but it's kind of exciting that we can help companies build up. So yeah, that's all.
Awesome. Thanks, Greg. I was going to give a quick plug for that book. If you haven't read it or watched, you can actually watch Ajay Agrawal give some talks. It's the first time I've heard someone talk about what AI might do economically that wasn't robots are going to take over and we're all going to die. There's actually real economics behind it, like a theory behind it, which I thought was quite cool. So it's because of the book that I met this guy. I went. Cool. So today we're going to talk a little bit about TensorFlow. So who here has used TensorFlow? Okay. Cool. How many people here are actively doing AI projects? A little bit of overlap there. Awesome. All right, so this is not as I said earlier, this isn't really a technical deep dive so much as an introduction to what TensorFlow can do and some examples of things that it's got done. Okay, so stop at any point. We will be able to, look at that, can't even see it. I will also direct you towards tutorials and other resources if you want to dive deep and really learn how to code. It's just this isn't the room for that. So starting from scratch, because we have a mixed room. Most people are using an AI library that provides most of the code. People are rarely coding AI from the ground up, thank God, because that's a lot to do. Things like PyTorch, things like TensorFlow. Microsoft, not surprisingly, has one. Caffe, Piano, there's a lot of them actually. TensorFlow is one of the most used, if not the most used. There's a bit of a religious war between TensorFlow and PyTorch. Not really, but there's people that feel strongly about one versus the other. All of the cloud providers have an interface that you can. So I've listed some of these. Amazon has SageMaker and a bunch of other things as well. So they're all doing this because if I can pull you in to build your ML models on my platform, then you're going to wind up buying other services. Not surprisingly, one of the things you'll see in a moment is TensorFlow sits in the middle of a network. It isn't the center, but it's the middle of a network of 50 other things that Google can provide for you, from storage to servers to other things.
Is it possible to run it without using Google Cloud?
Yes, it's on Amazon at least.
If I have it on my own server, can I run it there?
Yes, we'll get into that in a minute. Not only that, the other question you might ask is it possible to run it on a device? And the answer is yes, so we'll get to that in a second. They've actually purposely taken some of the core learnings of it and put it into a bunch of different packages so you can do some pretty cool stuff.
So could you go back and show us the slide with the Wi-Fi password? Okay,
Okay. Anybody else need it? Let's go back. So 30 West 26. Cool. So a way to think about, and this kind of gets into the reality of building an ML model or an AI product specifically, is there's the execution of the thing, which is going to require it run on servers, but there's also the building and testing of the model. And in a minute, there's a really cool interface that they have on TensorFlow that allows people that don't play with models a lot to get a sense of how much playing with models you're going to need to do. Because you can actually just run a bunch of different things. I'll show you that in a second. So one of the things that TensorFlow does that a lot of people really like is there's a separation in how it's built between how you're making the model and then how you're executing it. The big benefit for that one is you can in real world applications, you can scale it a lot more easily because of the separation between the two. Because you can deploy it on different things. If you want to deploy it on a smaller kind of server or whatever it is, or you want to do something that's bigger, you can swap that out. In the case of TensorFlow, Google also has these things called TPUs. Has anyone heard of TPUs? TensorFlow processing units. So what they did was they said, oh look, machine learning has been dramatically accelerated because people realized it runs faster on a graphical processing unit. And they said, let's take that and push it as far as we can. So they built these chipsets called Tensor Processing Unit, TensorFlow, I think it is, processing units. It's either Tensor or TensorFlow, whatever. And they actually have racks and racks and racks of them, and they're just a dramatically faster way to execute. And they're, of course, updating them every 15 minutes, too. So you can rent TensorFlow processing units, which is pretty cool. The point being in all of this is I may build something that I've maybe 10,000, 100,000 data points, and I'm using it on a pretty small number of users. And then I might say, oh my God, this is really working. How am I going to scale this? It's a lot faster to do with this architecture than with some other solutions. So the two pieces are, as I say, interface for expressing machine learning algorithms and an implementation environment for executing. And again, they make their money on the executing part. Of course they do, right? That's where you get all the services that they sell. The other piece that's interesting is, a lot of you may know this, but if not, I'll tell you. Most production AI has more than one model in it. You think about Google Translate as a really easy one to understand, right? You've got optical character recognition, you've got different things for different languages, you've got voice, you've got all this other stuff. So who knows how many models, they know how many models are in it, but I don't know. The point I'm making is a lot of times in the real world, you're going to want to stack models on top of each other. Because the reality of a machine learning project is that you want to keep it as narrow as you can so it'll train instead of never training. So if you're able to do that, TensorFlow allows you to stack them together more easily than might otherwise be the case. Does that make sense? Water. So just because I'm a geek and I liked knowing this, what's a tensor? Anyone know what a tensor is? No cheating. It's an array of data. And so the idea being is a tensor flows from one part of the system to another, and you do operations on the way. So technically, this is, really all of those are a tensor, but you might say that a scalar is one number, a vector is a string of numbers, a matrix is more than one string, and then a tensor is more than one matrix. So the idea being, if you think about a real data set, it's going to have not just one long string, it's going to have multiple strings that you're flowing together. So that's the name TensorFlow. I don't know why, but I dug knowing that. So why do we like TensorFlow? So many of the interfaces you run across are too high level. especially if you're not deep into coding yourself. So you can access a lot of pretty good, especially voice, a lot of either code-free or code-light ways of doing AI, and as opposed to diving in a little bit deeper, and you can do both. So I use Dialogflow as an example of some of the interfaces that are kind of high level. Tensorflow, like PyTorch, is actually, it starts as a low-level library that they've built a lot on top of. So it has both levels. You can go either higher level APIs, Keras being one of them we'll talk about in a minute, but you can also dig in as deep as you want and hand code as much as you want. And it's pretty cool that they've built it so that you can have all the control you want, or you can have the speed of taking templates and things that people have already built. In today's open source world, that's a nice thing. So as I mentioned, it has a set of high-level APIs and a GUI that allows intuitive testing, which we'll look at in a minute. There's actually two of them. And then the scalability, I mentioned earlier. It's built for scales that quickly go from test models to production in the same environment, so you're not porting things all over the place. It just speeds things up, and it means that you can test things where you're going to run them as opposed to otherwise. Okay? So, and just because sometimes these things that we see, we're not sure that they're being used by real companies, TensorFlow is. So it's the real engine, it's not something for toys. Whereas Dialogflow, you wonder a little bit about that, right? So Dialogflow, for those of you who don't know, is a voice solution that Google bought. It is running real things, but most production that I've found tends to have another NLP model than Dialogflow. So diving in just a little bit, because we're talking about deep learning mostly, and deep learning is stacks of things that are doing different operations. Something you might not have normally cared about, you care about, and that's computational graphs. So it's separated into, this is the same thing I mentioned earlier in terms of what the model is and then the execution. So you're separating it into computational graphs and then the runtime, the environment to execute them in. A way of for those of you who don't use this word a lot, a way of thinking of a computational graph, it's just an abstract way of talking about what you're doing. This is kind of a goofy little, I just like it because it's got squirrely things. But basically you're saying this piece is going to connect to that piece, and when the data flows from here to there, we're going to do this to it. So it's a way of looking at your operations without code, so you can think about it abstractly and think just in English. Here, this is going to do this to this to this. And again, some of the big breakthroughs in deep learning have come because people have thought like this. So they thought, for example, about how we're going to do images. Well, what if we take sampling of the images, and the point of a convolutional network is it's taking samples in a row. That's a different way of thinking at a really abstract level about how you're taking data in. You guys, I don't know if any of you are familiar with how convolutional networks, how the CNNs work, but that's what they do. And it's because of thinking like this that you're able to do that. And TensorFlow has made a point of allowing you to visualize these things. They have a thing called TensorBoard, which I'll show you in a minute. This isn't, to be honest, programmers do this all the time. This just happens to be, as I say, more relevant for those of us that are foot in both worlds. So the nodes in the graph are basically operations and variables. So you've got your data and then the thing you're doing to it, right? Variables flow through operations. Again, this matters because you'll often be experimenting with different operations. So as you're playing around in an environment like TensorFlow, you might say, okay, I've got 14 hidden layers. Let's try a 15th. Okay, well, what are we going to put in that 15th? This allows you to separate out the deep specifics and think a little bit more high level. Because those are the decisions that you make as you try different models and you play around with them. So separate, you avoid scaling issues. You can try things out in a fast, light, and cheap environment. Once you've built the model and tested it, you can scale it almost without limit, as I mentioned earlier. That is the code below, that is what it looks like as a computational graph. So it gives you a really simple example. It's obviously not a machine learning graph. And for those of you who maybe hopefully can all see it, this is how those two look in actual code. So phase one is figuring out what your graph looks like, what your code is doing. And this is saying, all right, I want to run it in what they call a session. So, I mean, this is the great thing about a lot of this stuff is it's even when you're writing code, it's quite abstract. So you don't need a lot of lines of code to get a lot done. You need to know what the lines of code do, obviously. But you don't need a lot of lines of code to get something good done. Any questions? Okay. So I mentioned before, you know, the point of talking about these graphs and all that, again, is because in the case of a deep learning network, you're going to want to know and think about what levels you've got and what you put in those levels, right? And this, again, is a really simple example of it. TensorBoard visualizes it for you. So the relevance of this is they actually have a product in TensorFlow that allows you to look at this stuff and see what you're doing. Again, that's the same thing as this, just in TensorFlow. So there's two, I'm going to go through, half of you probably know what this is, but it's for a reason. When you think about supervised learning, there's two main things that we're doing that at least that are relevant here. One of them is prediction, so if you tell me X, I'll tell you Y. The other one, though, is classification. Is it a dog? Is it a cat? Is it a Maserati? The reason I wanted to refresh you on that is because of the next slide, is to illustrate a little bit about, that is also a graph, a computational graph, but now you're talking about a pretty simple, really simple actually, deep learning network. Right? So the steps involved in creating and tuning this thing can get confusing. You can lose track of the fact that I've got 100 layers and each of them has, you know, some of them have 150 nodes in them and some of them have whatever it is. So being able to visualize it just allows you to have intuitive access to what you're doing. Yeah, we saw that right. And here is where, so we've now looked at visualization and kind of understanding it. There's a thing called a playground. Has anybody ever looked at TensorFlow Playground? Awesome. The rest of you should. And I say that because you can dive in and begin to intuitively understand deep learning in a way that's hard to do any other way. And actually, I'm going to see if this will go live. So, and on the it's not. Yeah. No. Sorry, it's not projecting the bit that I wanted it to do. There we go. It's always easier when I'm practicing. So this is the actual site. And the reason I wanted to share this with this group is most of us are not going to grind away at tuning hyperparameters and all the bits that go into building a deep learning model. But a lot of it helps you to understand what goes into it. It helps you to have a conversation with the people that are doing that. And what I like about this is it's set up for that reason. So it's, and as I say, I'll put this on the meetup. But what you can do here is say, and the reason I also pointed out classification is that's what it's practicing right now. So it's essentially saying, you can barely see it, but how would I be able to, if I had data that looked like this, how could I create a model that will classify the blue ones or the yellow ones? That's not that easy. I mean, if you think about normal regression where it's in a line and you can see what's on one side or the other, that's easy, but this is not because the shape is it's a circle. How do you do that? So what they allow you to do here is you can make decisions about, you want to add a hidden layer, you can add a hidden layer. On that, you want to add some neurons, you can add neurons. You want to start with that, you want to start with that, you want to start with some other. So the point being is you can start to play with what's important. Now, in machine learning, there's a term called epoch. Have you guys heard that term before? Again, half the room has. Epoch means that you've run it once. Why they use that word, I don't know. It sounds really grand, but it just means they've run it once. So what you would wind up doing is run it a bunch of different times, and of course it's really fast. And you can start to see what they call a loss function. So you see the output there? Loss function is a measure of how accurate you are. And the value of knowing all this is you can dive in and hit this. You see how the lines are going like that, and as it starts to look more and more like that, it says that it's gotten good. So sorry, I think it's stop here. So you see the loss now is like nothing. It's 1,000th of a, or 10,000th of a percent, like nothing. So that's the value of doing this is you can go and say, great, that's how good we got for this, and it took me 185 epochs to get there. What if I do less of this and don't do that, but do this instead? What'll happen? You can redo it, and you can see how it's learning, which is really cool. So I found when I started working with this, it gives you a really good intuitive understanding of what's going on in deep learning, for those of you, again, who are not actively playing with models. All right. Yeah, we're off a little bit. Oh, there we go. So I encourage you to literally play around with the playground. It's a nice way to get an intuitive sense of how deep learning works. So we talked before about high level. Sorry, there's so much writing up there. I got a little crazy. What is happening right now is TensorFlow has increasingly implementing this. Keras they didn't come up with. They've just pulled it in because it's open source. But it's a fast prototyping, advanced research production with, there's 3 things it does that are great. So anybody here heard of Keras? Probably the same group. I'm going to stop asking. You guys! Anyway, Keras is one of those things you hear a lot in machine learning. It's been around for a while. It's a great high-level way of accessing kind of deeper things. Consistent interface, optimized for common use cases. I stole this from them. I'm sorry, that's why it's so long. But it's modular and composable, so you can make a lot of this stuff is meant to be modular, and you can pop it together and use it together and reference it very easily, like most modern software. Easy to extend. So they writing custom building blocks, all this, you're meant to be able to reuse and save things and connect them to each other. There's an interesting thing that they've just started to do. So the idea is the model is a great idea. Sometimes you just want to look at how code works without having to do boxes and connect it all together. So the opposite reason, so on the one hand, being able to intuitively access and understand what's going on is what the graphics side helps you with. But sometimes when you're writing code, you want to just see it work. And what they've started to do they're doing it now in TensorFlow, is what they call an eager execution, which means you can just execute it really quickly, little pieces. So if you've ever dealt with a Jupyter notebook, so Jupyter is in Python, they make notebooks which are little development environments that allow you to execute code in little pieces, which is really nice. That's what this allows you. It's similar to what this allows you to do. Just easy. It's much more code-based and it's the way developers work a little bit more than some of the graphical pieces. That said, if you're new to this or you want to play around with this, Colab is a Jupyter notebook. That's how you spell Jupyter for those of you who are curious. It's a Jupyter notebook that allows you to access TensorFlow and execute things in TensorFlow pretty easily. So it's connected automatically. In fact, in a lot of TensorFlow pages, there'll be a little note that says click to Colab, which is nice. So you can try things out really easily. The whole point, again, of notebooks, for those of you who haven't played with them, is they're a quick, easy little environment where you can try things and you can pull the code out if you need to. So Colab is pretty, I really like it, to be honest. Now the other thing, and I'm going to see if we can make this work, which will be really fun. They've also, so this is kind of getting at your point earlier about where else you can run TensorFlow. Do I need to be on the Google Cloud platform to get it done? The big stuff you probably do, but they've made an implementation where you can actually access it code with just JavaScript, which is great. So you can run things in the browser. So in this case, they actually have a whole page of stuff like this, but in this case, it'll use the computer's camera to sense where you're moving, which is sort of fun. And they're just using JavaScript for that. So for those of you who are JavaScript developers, there's already a library that's pretty easy to turn on. It is not going to drive your car. It's worth keeping in mind that really, really powerful models take up a lot of space and take up a lot of compute time. And you're probably not going to train too much on this either. So a lot of the big compute is training the model, and once you've got the model trained, it's a lot smaller. But if you want to train something new and difficult, this isn't the way to do it. It's a great way to execute and reference other models though. This? No. It's on your browser. I'd recommend you use Chrome, but it works on Chrome and Firefox.
But you're not running the calculation on your laptop. Is it?
Yes. That's why I was saying it's not going to do heavy stuff. It'll access other models, it'll do other things, but you're not going to train something with Tensorflow.js. You're going to run little models on it. Check it out if you're interested, and they'll pretty clearly tell you what the limits are. Now, the other piece is increasingly, if you haven't come across this yet, you're going to start hearing it, that people want to be able to do AI at the edge, on your phone, on your local computer, instead of having to send it to the cloud. The amount of data that isn't necessary to send back to shouldn't be necessary to send back to the cloud is huge. I mean, you don't want to have to send every little pixel back to wherever their data center is. So what you're seeing is in Apple, they have a thing called ML Kit, so you can do things on the phone. This is sort of the equivalent, except it does more, obviously. Of course it does. But the whole point of this is building models, possibly training them somewhere else, but then implementing them on the edge, on an actual device, so you're not dependent on bandwidth, you're not dependent on the whole Google Cloud infrastructure. It's a really cool way of taking what you've done and making it into a production model. So you think about things like again, image classifiers. Once you've trained that, you shouldn't need to go send every little duck or dog back to a data center, and you don't have to anymore. So TensorFlow Lite is good for that. So the way they're describing is you're picking the model, either making or retraining an existing one based on their parameters. You convert it to a compressed flat buffer, which of course everybody knows what that is, in the TensorFlow Lite converter. So basically they have a process that they have to choose it up and puts it back out. You take the TF Lite and fold it into load it into a mobile device, and then you play with it and optimize it. So the point is there's a nice, easy, clear workflow to go from a model that you've created somewhere else. So a lot of this stuff that's either on the edge or on the browser, you're probably not training a model. You're probably taking a model you've trained with some heavier machinery like TPUs, and then once it's been trained and you're comfortable with it, you can export it in different ways, and this is just a good way to do that. So it's worth remembering when we talk about stuff like this, because I think we sometimes don't remember. Training a good model is data in the hundreds of thousands and millions, and in enormous numbers. So again, this wouldn't be for that. This would be once you've gone and done that. So how many here have heard of Kaggle? Yay. So Google bought Kaggle within the last year. I forgot when it was. And they've really incorporated that as well as the fact that they're Google, and they probably were doing it anyway. So one of the things that I mentioned, when I was mentioning earlier, that to train a model you need a lot of data. Most normal humans don't have millions of data points. So it is often the case that you can find a data point that's close, train a model, and then tune it on data like yours. That's increasingly the case. Actually, as of October, that's sort of the case with NLP, with the BERT model. But regardless, when you want to look for data sets that are close to what you're trying to solve, that's what Kaggle's for. Well, anyway, that's why everybody loves it. Kaggle's for making $1 million on a competition. They do that. They have competitions, and the prizes are insane. But if you are thinking about trying something or building a model to do something, this is not a bad place to start looking, or just go to Kaggle itself. But you'd be surprised at the data sets that people offer up there. There's a lot of really good stuff. Of course, they won't have exactly what you want, because that's the way life works. But they'll have things often that are close. We did a text classifier for calendars and found Reddit data that got the job done. It was a pain in the neck, but it got the job done, as an example. So, yeah, how does that fit into a workflow, right? So essentially, and this is where we're about to go, we can go through exactly these steps. So if you want to go from, and they have a tutorial that takes you through every one of these steps, because of course they do. It's effectively saying, if you buy my stuff, you can do this, then this, then this. But signing up for a Google to create a cloud, if you have a Gmail account, that's good enough. You don't need to give them a credit card. Explore and visualize a data set to create a TensorFlow model. So again, there's actually a tutorial under this. But everything we talked about earlier, if you've decided what problem you want, I want to be able to classify whether a cat has white hair or not. Whatever. So they all do. So I'm going to get, 1 million pictures of cats, and 100,000 of them have white hair. Again, I'm making it up, right? So I have this data set because I went to Kaggle. You found it. I put it through, and I played around with what I want my model parameters to be. How deep do I need it to be? How many convolutional, what layers do I need? Pooling layers, all that. So I figured all of that out. At the same time, they have the ability for you to hold off your sample data set. So for those of you who haven't gone through the process of creating a machine learning model, typically you're taking about 30% of your data, depending, as test data later. So you're training it on 70, and then you're validating whether your model works on another percent. So this is already kind of baked into the workflow. Does that make sense? You guys clear on that? That whole just holding some aside, because if I put 1 million data points through it and I've tuned a model, it might only work on that data. So I want to take similar data. So again, just a standard thing is you pull 30% out or something like that. Some people do more. I think 30 is fine. You're training and evaluating the data sets. You can execute. You can spell training properly, and you can deploy your AI service. So the point of all of this is the flow is all in there, all of the pieces that you need. And again, I chose Tensorflow because I happen to know it. The same thing is true in Amazon. The same thing is true on Microsoft. And the same thing is true in IBM. IBM tries to abstract things a little bit. You can go down under it, but a lot of times IBM tries to give you things that a business person can use, which is, I'm not sure how true that always is. But all of them can do something like this. Again, I just chose this as an example. I happen to also find that they really do a good job of tutorials. You can actually get, if you wanted to spend not that much, but a little bit of money on Coursera, there's some fantastic courses that'll go through this, but they have their own. If you go to the one I'm about to show you, let me get through one thing, and then we'll see, because I think we've got some time. So having gone through a quick explanation, and again, since we do have time, I'm going to dive a little deeper into what we just looked at. We've got a whole online kind of tutorial we can look at. But if you already know Python, I would encourage you to dive in, think of the thing that's interesting to you, and go find it on tensorflow.com. There are a ton of really good workshops and tutorials. They make it really accessible. You can build something and deploy it incredibly quickly. I mean, the top line point of all of this, for those of you that are entrepreneurs, for those of you that are engineers that aren't working in machine learning and AI, this is really accessible now. Obviously, when you want to put something in production, you're going to want a data scientist, but you can get a lot done with some simple Python commands. You don't need to write big Python code. There's some simple commands that don't take that long to master. The point of doing that is you can test and try things out quickly and relatively cheaply. For production, you're going to want to invest a little bit more. But we're not in a place where it's difficult. We're not in a place anymore where no one knows how to do this. It's all pretty accessible. And TensorFlow is, again, the point of today is it's really accessible for most people. So if you don't already know Python, learn basic Python 3. So if there's a Python 2 and there's a Python 3, don't bother with Python 2. The only reason it's around is it's a really good language and it's been around for a while. Python 2. And then do a workshop in TensorFlow. To be honest with you, if you were to go and do the Coursera version of this, they'll teach you the Python you need to get an understanding of it. You won't be able to do production models, but they'll teach you what you need. So in April, just especially as 1 or 2 people going, we have another. So this will be bi-monthly now, if I can get that out. Bi-monthly. So the next one will be in April. We'll talk about deep fakes. In fact, Frank's coming back, if you remember from a while ago. Samsung has an in-house machine learning specialist who's going to join us, and then we've got one other that we're just confirming. So, sorry, wrong direction. What I wanted to do now, first of all, any questions on that? I kind of flew through it, but now you guys have an understanding of what TensorFlow is, how TensorFlow works. Yeah.
Might be a bit of a difficult question because it may be too specific, but like if you're somebody who already knows, like I programmed neural networks before there were packages, I got out, and I'm wondering like what does it offer to somebody, like what kind of, are there just a lot of extra tools in the package?
Yeah, I think that the biggest thing for someone like you is different. You can choose the level of abstraction you're comfortable with. Mm-hmm. Do you know what I mean? Like you'll have an intuitive understanding of hyperparameters that most people won't, for example. So you may not need that level of abstraction. Mm-hmm. But you can also, in this environment, speak with people who are maybe a little bit less intuitively sophisticated than you are. You know what I mean? But it comes with a lot of what you're going to need already, and it's faster.
Yeah, okay, no, that's...
and that's
yeah.
probably the biggest one, is if you need to, roll everything by hand, it takes a long time to realize, oh, we should just go over there. So a lot of the value here is it's abstract enough that you can try a lot of things.
Can you talk a little about TensorFlow 2.0? When can I see it?
It's funny you should, so TensorFlow, this is TensorFlow 1.2 or something like that. There's a couple of them out there. They don't know. I couldn't find it. They announced it last, like, August, I thought, right? Something like that. So TensorFlow 2.0 is just, it'd be another iteration, and things like Keras, which I mentioned, you can use, but it's not integrated quite like it should be. So I don't know. I couldn't find an announcement. It's a great question. It's just everything you just saw, but more. It'll be easier to use. It'll be faster for people that can write some Python to be able to test and try some things out. And as ever, more integrated in all the stuff they do. So I don't know. Anything else? Awesome. So what I wanted to do is, this is going to... So this is a presentation that goes along with the last slide I was showing you, which is sort of an end-to-end look at Google's environment and how you can go from literally nothing to building a machine learning model. And I'll go through it kind of quickly. But this is their representation of TensorFlow on their cloud that they call their cloud ML engine. So something's got to drive this. TensorFlow isn't a server, right? It's the software. So it's running on something, and they have servers and all the rest of it that's optimized for running this stuff. So these are the specific pieces of TensorFlow that you're going to use for different things. I'm not going to get into those too much right now. You don't need to use all of it. So you're not going to be writing core TensorFlow with C++. Python, probably. Some of the other ones are not even writing Python. Again, you're just doing some quick commands. Yeah, gotta love the humility. We don't work with toy problems. So they're kind of saying that a lot of the frameworks that you can get, and that's true, there are a lot of machine learning, Python machine learning libraries out there that are tough to scale. You can get some stuff done, but they're tough to scale. They're not integrated in an environment. They're made for smaller things. And their argument is that, in this environment, you can do a lot more. So they're saying, and this makes sense, you need a lot of data, right? And how you manage, I don't want to get into this too much, but how you manage the data it also becomes really important. So feature engineering is what I kind of showed you before. So feature engineering is how many layers do we want, how many neurons do we want on it. Those are the decisions that you make to make the deep learning model work. All right, so how many transformations do you need? And then model architectures. So anyway, they have a lot of them. Sorry, I want to get through this kind of quickly. So again, this is just a kind of review of how it goes from pre-processing through all the pieces to your web application and creating an API at the end of it. And I want to get to something a little. I think we'll end here. So the net is I encourage you guys to go and go through this. When I looked at it before, I didn't realize quite the level of detail it gets into. So anyway, that's a kind of a high-level overview of TensorFlow and all the things that you can do with it. Kind of encourage you guys to check out tensorflow.com if you're interested, and you can dive in a little bit more. especially if you're looking at for specific use cases and specific things you want to do. What I wasn't able to find the cleanest way to do, one of the things that Google keeps doing is coming out with and publishing pretty amazing models. So in October of last year, they published something called BERT. Has anyone heard of BERT? Other than the fact that it's, Ernie. So it means bi-directional, and then I don't remember what the rest of it means. The point is, it is it's a bit of a breakthrough in terms of natural language processing. So they published the paper, as I say, I think it was in October. They published it on the Google platform sometime towards the end of last year. You can access it through TensorFlow. Same thing is true for those of you who remember when the Go champion was beat by DeepMind 2 years ago, basically. That model is they published, they call it dopamine, which of course they do. These names are amazing. We've got BERT, we've got dopamine. I would encourage you to check out the paper about dopamine. Is pretty cool. That's reinforcement learning. Again, you can access that through TensorFlow, because it's just their umbrella to put things under. So as you begin to learn how TensorFlow works and get comfortable with it, you can access some amazing things. And if you think about it, 2 years and 1 month ago, or I'm forgetting quite what the date was, but over 2 years ago, we didn't think that a computer could beat the world champion in Go for a decade or two. We thought it was so far off. And not only did that happen, now you can access the model that did that. You can do other things with it, but that approach is available to normal people. That's pretty awesome. Same thing is true with BERT. The specifics about BERT that are really great is it is a massive NLP model, and you can train the last layer on what you're specifically interested in. Whereas that was really hard to do. It was hard to use what they call transfer learning in natural language processing in the past. The second half of last year saw a sequence of things that made it better and better. So again, one of the reasons why I was attracted to TensorFlow amongst the other options is the ability to access some of these amazing other things that they're publishing. And they're crazy. They're publishing new stuff all the time. So, guys, that's it. That's what I've got for today. Any other questions? Awesome. Well, guys, I hope to see you in April when we've got another meetup. Thank you.